Hi. Today we're working on a customer's music and sound model MC602. The MC602 is probably by far the most common music and sound model that we get here at the shop for repair. They have certain inherent problems. This one had way more than that. The report from the customer was this unit was installed sometime in the late 1990s. About 8 or 9 months ago, suddenly it went dead one day, like completely. Nothing worked, display was dark, nothing at all. What they found was that the two fuses on the main board had blown. So they went down and got replacements and put those in, and the report was that after a day or so, those fuses blew also. After that, they got more fuses and put them in, and the cycle seemed to repeat over and over again. The order of events seems somewhat disjointed to me. I'm not exactly sure, but what I did find ultimately after they sent it to me was indeed they had replaced the fuses. They had the wrong type of fuse. They were too large for the fuse holders, but also they broke one of the cardinal rules, which was they put in higher rated fuses. An MC602 uses two 3-amp fuses. What I found in the set were physically larger fuses, and they were each rated at 5 amps, and they were also blown. The reason that you don't put in larger fuses, which is a common mistake people make, is the fuses are there for a reason. They're there to protect circuitry inside the MC602 that's only designed to draw so much current, probably in this case 2.5 amps or so, maybe 2.8. And if you exceed that, it blows the fuse because there's obviously a problem. If you put in 5 amp fuses, then you're moving the threshold of failure up to the point that whatever the problem is that's blowing the fuses is going to be more dramatic, and instead of blowing the 5 amp fuses, it may fry components on the circuit board, which is what the fuses are there to prevent. So it turned out this MC602 had just about every possible problem that an intercom could have. It had a failed primary power supply. It also had a failed amplifier. It has a failed AM/FM tuner. It's got bad intercom switches. These I think are probably okay. And it took a lot of work to sort through each of those individual problems just to get it to the point where I could power it up. So I rebuilt the power supply, I rebuilt the amplifier, I repaired the tuner, and eventually got it to the point that it would power up and it actually would do something. It actually plays music now. However, there's the rub. When it plays music, it sounds like, please pardon my French, crap, because there's an underlying distortion in the sound. It's not super severe, but one of the things I explain to people often is, and I explain it when it has to do with sound on an intercom system. Oddly enough, I also explain it to people when they were talking about NuTone door chimes, like Westminster chimes. Everybody inherently knows what it's supposed to sound like. You know what a radio is supposed to sound like when it plays. You also know what your door chime is supposed to sound like when it rings. When it doesn't sound right, you can try to convince yourself that it's okay. You can play with the bass and treble and volume adjustments and tweak them and try to adjust the distortion out of the sound, but it's still there. You can't make it go away. You might be able to convince yourself it's like, nah, that's all right. That sounds pretty good. You know, it's an intercom. That's just the way they sound. But when it's wrong, you know it's wrong. Tracking down distortion is by far one of the most finicky things to do when you repair something, especially on something like an intercom system. The way systems are designed for most models, for most manufacturers, it goes back to the late 70s or early 80s. They have a more integrated design. And what does that mean? Well, so this is the main board. It's upside down. This is the main board of an MC602. The tuner is missing. The tuner would sit here. I have it off the board because it's in the way because it covers up things. So we're not worried about the tuner so much. So how does this work? Why is it complicated to find distortion? The way you have to look at this is you have many potential audio sources. You have AM radio, you have FM radio, you have auxiliary input, you have tape input, you have chime input over here from a chime module. You also have intercom input. That's the communication part of the system. Each one of those are separate audio inputs. Intercom is an audio input because you're speaking into it and it goes through the system and comes out the other end. It's no different than a tape input or an AM input or chime input. They're all audio inputs. Back in the old days, the inputs were more discrete, especially on systems that had input knobs. There are some NuTone systems where when you switch the knob from AM to FM, you're turning the AM part of the tuner off and you're turning the FM part of the tuner on. That's how divided up the inputs are. On a design like this, all of those different input sources are on all the time. You're not turning the AM part of the tuner on or the FM part of the tuner on and the AM off. Everything is always on all the time because the system is on all the time. It's always powered up as long as you have electricity in your house. Also, those audio sources, AM, FM, tape, auxiliary, chime, intercom, they all feed through common circuitry on the board because of the use of our friend, the integrated circuit. So integrated circuits are little devices that have multiple circuitry inside of them, all super miniaturized, so they fit in a little thing like this, which makes it less expensive, saves space, products get smaller, it's all very good. But the problem that you have when you're dealing with something like distortion is, the question is, where is the distortion coming from? Where is the source or the flaw that's creating the distortion? If you have multiple audio sources and they're all feeding in through different integrated circuits that have little sections inside of them, you may have an integrated circuit that's basically an electronic switch. You may have 6 or 8 little electronic switches inside one integrated circuit. And each one of those switches is responsible for switching some input in or out or on or off. There are other devices, other integrated circuits on the board that do similar things. Each one has their own specific job. And the way fundamentally a set like an MC602 operates is the whole thing is controlled by a microprocessor. So when you push a button, and you tell the microprocessor what you want to do. I want to listen to FM radio. So you turn the power on, it tells the microprocessor, hey, wake up, we've got to do something now. So it powers up certain circuits, and then you push source, and you push it till you get to FM, and you're telling the microprocessor, I want to listen to FM radio. And then it looks up its instructions, and it follows that, and it does things on the board. The microprocessor is the brain. Brains think, but they don't want to work really hard. So they tell other components what to do, and those components do their bit. They do the heavy lifting and switch things on, circuits on and off. They're not switching the tuner on and off. The tuner is always on. It's always receiving signals from the antenna. It's always processing those signals. It's always on. It's always working. But outputs of the tuner have to be switched by other components. So ultimately you hear the FM radio play through. When you have distortion and the audio sources are going through components that do the same task but multiple tasks for different inputs, and you're dealing with distortion, you can have a failed component. This isn't it necessarily, this is just the example, that the failure, even though it's in one small section, remember the switch with 6 or 8 little switches inside of it? They're all electronic. They're not moving switches, they're electronic switches. You may have a failure in one of those little switches inside the component that's affecting the other ones also because the integrated circuit has failed. This makes it very complicated to find something like distortion, because distortion is a degradation or a flaw in the signal. And if components have signals flowing through them, a flaw in a component will affect the signal and make what comes out of the speaker sound wrong. So it's complicated. So how do you deal with this? Because it's not an easy thing to do. You have to be very diligent about trying to find the source of the distortion. It becomes what I refer to as a divide and conquer project. So you have one circuit board. It's not a very big circuit board. There's not a ton of stuff on it. It doesn't have 10,000 components. There are no microprocessors on this board. There isn't anything that's super complicated. It's all discrete components. Every component does its little individual job and they all work together and it becomes a radio intercom system. Very hard to deal with this on a whole. There's things you can do. You can measure voltages, you can look for physical damage, components that are blown up, which you don't find that often, but you do sometimes. You can look for water damage, you can look for all kinds of things like that. You have to use all your senses. You look, you listen, you smell, you touch, heat, cold, whatever it is. But it's easier if you can take this board and divide it down into smaller sections so you can eliminate certain groups, certain sections of the board as a potential source for the problem. And that makes it go faster because one section might contain 60 parts, 60 components. So if you can make a minor change to the board and you knock out those 60 components as a potential source for the distortion, your job just went away faster. Because let's say, for instance, it's this section right here, this bottom corner. If you can eliminate that as a potential source, you've now reduced the area that you have to search for the problem by a great deal. The way I decided to do this on this MC602 was, is the distortion being caused by some part of the outlying part of the board, or is the distortion being caused by the amplifier itself? Because that is a possibility. Now, when you do troubleshooting, you're looking for clues. Clues are information that you can use to focus what it is you're trying to do. One of the clues I had on this set was the distortion was in the AM, it was in the FM, it was in the auxiliary, it was in the tape, it was in the chime module, especially in the chime module. That's a whole nother thing. And it was in the intercom. It's a little hard to tell with the intercom because it's voice communication and that's hard to determine. Chime module is really easy to determine because music and sound chime modules, even in a perfectly working set, are not the best sounding chime modules in the world. They have this sort of reverberation thing that they designed into it to make it sound, as they would say, more melodious. I don't really care for it. It sounds like, reverberation is a kind of distortion. But you know what this sounds like because you've heard 1,000 of them that sound the way they're supposed to sound, and then you plug it into this set and it's like, whoa, it's like off the charts. Obviously something really wrong. Also with the radio and with using the auxiliary inputs on known good music sources, there was distortion. So you have distortion on all of the audio inputs, it seems. It seems unlikely to me that it would be some part of the outlying part of the design and possibly could be the amplifier. Now, the amplifier, not this one. The amplifier was rebuilt because it had blown up output transistors. One of them measured nearly dead and the other one was completely dead. And the one that was nearly dead obviously had been hot for a while because the plastic body of the package was discolored, and also the little nylon screws that held it to the heatsink, it was melted. You couldn't put a screwdriver in the slot because the slot was all deformed because it had been hot for so long. It takes a lot of heat to melt nylon. What we needed to do, because I wanted to narrow down, I wanted to divide and conquer the board if I could. I took a look at the board and studied it very carefully and looked at the schematic that went with it and figured out where I could tap in to the input of the amplifier and bypass all the rest. Most simple designs like this, and this is a relatively simple design, there is some point where everything comes together. It has gone through all of its processing and switching and all of the things that the outlying components do, and the signal then is fed directly into the amplifier. Now there's only one place that it feeds in because it's a mono system. It's a single channel amplifier. It's not stereo. So there's usually, if it was a stereo amplifier, there'd be 2 points. But in this case, there's only one. So what I did was I Frankensteined it. Yes, this is disconnected. So this is the back of the one we're working on. And what I've done here is I pulled a component down here off the board. I put a little bypass capacitor in there for safety and added a wire, and I have a ground wire here where we can send a signal into the amplifier directly and bypass all the outlying parts of it to see what we had. Because if it's an amplifier problem, that hopefully will be more straightforward to solve than if it's something on the rest of the board. And that's basically what this video is about. There's a lot of thinking that goes into working on something like this. The distortion in this set is not common, but it probably relates to the failed power supply, the failed amplifier. It has probably nothing to do with the AM/FM tuner. That's a different issue altogether. It has nothing to do with switch problems or anything like that. It probably most likely has to do with the amplifier and power supply failure. And one of the things you have to consider is on designs like this, and this is true for most intercom systems, primary power supply and the amplifier very closely tied together in their design. So if one goes poof, the other one's likely to have problems also. So I thought I would take a minute to do this video, and I'm going to show you what the distortion looks like and then what it should look like. So here's the setup. I can't show you both at the same time because we only have one camera. I have the customer's MC602 powered up. I've attached to it a signal input from an arbitrary waveform generator, basically a signal source, and it's tied into the input connection I added to the set that feeds directly into the amplifier and then into the ground of the system because that's the other side of the signal. And then I also have the oscilloscope, the Rigol DS2202A, connected to the output on the speaker cone in the master station. So what the oscilloscope will show is the actual signal that's being fed into the speaker in the master station from the amplifier because of the signal we're feeding into it. So I'm going to switch the signal source on and show you what we have. You can hear the tone. That's a 300 Hertz tone, and the signal being fed into the amplifier is 300 millivolts peak to peak. And what you can see here on the screen is this is our signal. Should be a nice even sine wave because that's what the arbitrary waveform generator is sending into the amplifier. But down here at the bottom, you have this large massive blob, and this is our distortion. This is what's causing the crappy sound that comes out of the speaker when we use the MC602. So now we've learned, most likely, it's not 100%, until whatever is causing this problem is solved, so our signal is clean. We don't know if there's anything before that, any of those other outlying sections of the circuit board that could be contributing to it, but odds are our problem is in our amplifier. And just to be fair about it, I'm going to take another MC602, one that I own, and I'm going to replace the customer's with mine so you can see that the methodology is true. So this is our new setup. I've replaced my customer's MC602 with a known good MC602 that I own. I've done the same modification to it where I removed the component, added a bypass capacitor, added 2 leads so I could feed a signal into it, and then I have it set up to the same arbitrary waveform generator. I have the oscilloscope attached to the terminals on the speaker cone so we can measure it, and now you can see what a properly working amplifier in an MC602 is supposed to look like. You can hear the tone, same input voltage. We'll scale this, and there is our proper sine wave. That's what it's supposed to look like. It's a nice clean sine wave. There's no clipping. Clipping is the top of the peaks flatten out because the amplifier runs out of power. It can't process the signal. It doesn't have enough reserve, so the tops get clipped off. That's very bad. You don't want that. And it's a nice even sine wave with no distortion on the bottom at all. That's what it's supposed to look like. That's the goal of the repair. Let me stop the noise. that's the goal of the repair on the customer's unit, is to solve that problem, hopefully with just the amplifier, get rid of the distortion, so I can get the darn thing finished up and we can send it back to her. So that's what I'm going to do now, and then I'll be back. Much time has passed, probably more than an hour. And after extensive troubleshooting of the amplifier circuit in the MC602, what I found was 2 small film capacitors that had failed and a diode that was breaking down after it was on for 10 or 15 seconds. When you would check the diode out of circuit, it seemed to be fine, but it was, as it warmed up, it became leaky, and that was contributing to the distortion. So I have the customer's MC602 set up just as before, powered up by its own transformer. I have the oscilloscope connected to the output terminals on the speaker that's in the master station, and I have my waveform generator hooked up to it. And if we send the signal in, there's our sine wave. As clean and as perfect as it possibly could be, just for fun. So if we change our frequency, we can go up. That's 1,000 hertz. Enough of that. All right, so now the next step will be to completely reassemble the MC602, take my bodge out where I'm feeding the signal into it, and put the tuner back in, hook it all back up, and in the end, the acid test is, what does it actually sound like in real life? Because that's what matters. So that'll be the last part of this video, I hope. After a lot of hard and diligent effort and troubleshooting that led to a good end result, our distortion is gone, and now when we play the music, and I can only do it for a few seconds, power on, good strong FM station. If we ramp the volume up, other than that we're driving the speaker much too hard for what it is, there's no distortion, it sounds great. And what I can show you is if we ring the door chime, I told you about the chime module before, that's this connected in. If we ring it, this is a 3-note chime module. While it does have the classic music and sound chime module sound, which I'm personally not a big fan of, but there is no warbly, garbly distortion in the tones anymore. It's nice and clear, and it sounds just like what music and sound wanted it to sound like. So in the end, it was a successful, if not daunting repair, because these are all of the parts, including the one that fell on the floor, that had to be replaced. All of that, and those, and the one that fell on the floor. Oh, and these 2 over here. Sometimes things fall out of the little metal cups. It was a good repair. It was a more interesting repair than average for around here because it involved thinking. And thinking is always a good thing to do. It opens up your brain, makes you look at things differently, come up with new ways to figure out how to test things, to figure out what's going wrong, and that's all good. That keeps the day moving along well. I hope you found this interesting, and perhaps for someone it will be helpful. If it is, give it a thumbs up. Thumbs up on YouTube, because that helps us just a little bit. There'll be a banner right here that shows you how to subscribe. Go to our YouTube homepage, click on the bell, and when you click on the bell, click on it to receive all notifications. And every time we post a new video, you'll get a notification and you can watch it. That's all for today. See you on the next video.